All right, guys, this lesson's on tangents. 2 pages of notes to go kind of fast, let up Pythagorean theorem, and then the second page goes a little bit quicker, not as much detail to get into. So here we go. A tangent line intersects a circle at exactly one point, called the point of tangency. So diagram over here, right here. Point A would be your point of tangency, right? It intersects a circle at only one point. So this is your tangent point right here. It says a line is tangent to a circle if and only if it's perpendicular to a radius. If you don't know what a radius is, make sure you have your circle notes right next to you. Drawn to the point of tangency. So this is the radius. The line of tangency will meet that point at 90 degrees. Okay. So check out numbers 1 through 8. Determine if AB is tangent to circle P. Well, here's how I do that, right? I know that this angle right here is 90 degrees. This is the radius. This is your line of tangency. You got to use Pythagorean theorem. So does a squared plus b squared equal c squared? Well, let's check it out. 8 squared plus 15 squared, does that equal 17 squared? Left side adds up to 289. Right side adds up to 289. So yes, they are equal. Let's try 2. Here's my 90. That's the radius. That's line of tangency. There's my 90. Does a squared plus b squared equal c squared? Well, time out. Remember, all radii in a circle is the same measurement, right? So if this guy's 11, this guy's also 11. So that side would be 16, right? A squared, b squared, c squared. 11 squared plus 14 squared, does that equal 16 squared? Left side adds up to 317. Right side is 256. They are not equal. That is a no. All right, 3 to 8. If JK is tangent to circle L, find X. Okay, so it's telling us that JK in all of these is tangent on all of them, right? So put your 90 in first, good reminder. Then we got to solve it, right? A squared plus b squared equals c squared. 7 squared plus 19 squared is x squared. Left side is 410. We square root. That comes out to be 20.2. Number 4, put in your 90. A squared, b squared, c squared. Well, once again, that little piece is 11, right? 7 11 is 18. X squared plus 11 squared is 18 squared. Subtract the 11 squared over. That gives us 203. Square root that. That comes out to be 14.2. Number 5. Here's your 90. All right. A couple tricky. I know this piece right here has to be 10 as well, but I'm not going to get into a quadratic type of equation. We're just going to call this entire piece over here y for a second. I'll show you why we're calling that y once we get done with the problem. So let's do Pythagorean theorem first. A squared plus b squared equals c squared. So 24 squared plus 10 squared equals y squared. Left side adds up to 676. Square root. That comes out to be 26. Okay, now here's why I did that. So this whole piece over here is 26, right? Well, I've got 10 of it right here. So if I take that 26 minus that 10, what's left for this piece? That'd be 16. So x would equal 16, and that is your answer. Number 6, a little more straightforward. Put in your 90. Now check this out. If this radius is 11, this radius also has to be 11, right? So this entire side over here would be 22. A squared plus b squared equals c squared. X squared plus 22 squared equals 25 squared. Subtract the 22 squared over. That gives you 141. Square root that, 11.9. Number 7. If this is 3.5, that's 3.5. So the entire side over there is 3.5 plus 3.5 is 7. Here's my 90 right there, angle J. All right. A squared plus B squared equals C squared. 7 squared plus 6.4 squared equals X squared. Left side adds up to 89.96. Square root that, 9.5. All right. 90 is angle J. Once again, I'm going to call this entire piece Y. Okay, and I'll show you why once we get all done again, but right now it's called the entire piece Y. Here's my 90, there's the A and the B, there's your C. So we got 7 squared plus Y squared equals 25 squared. Subtract your 7 squared over. Oh, that gives me 576, square root that. Comes up to 24. Okay, now check this out. So this whole diameter is 24, right? If I cut that diameter in half to get this extra here, that would have to be 12. The whole diameter was 24, cut it in half to get the 12. Next page. Number 9. All right, this one's a little bit trickier. We're going to hold this up for honors, guys. Do not worry about number 9. It gets into a quadratic equation, which you guys have to do some factoring, and we're just not quite there yet. Actually, you know what? No, it's not. This is going to be just fine, actually. We can do this. Check this out. This radius is x. This radius is x. The expression for this side would be x plus 10. All right, a little tricky. You will not see this one on a quiz, but it's good for some homework, I guess. 90 is angle J. A squared plus B squared equals C squared. X squared plus 20 squared equals X plus 10 squared. All right, here we go. Remember, guys, X plus 10 squared is X plus 10 plus X. Get to go back to algebra 1 for a second here, right? Remember the FOIL, first, outer, inner, last, all that good stuff? All right, so when I break that down, it comes out to be this. We'll have an x squared plus 20x squared plus 100. Here's why we can do this one. You got x squared on both sides. See ya. They're gone. 20 squared comes out to be 400 equals 20x plus 100. Subtract the 100 over. And then 20 goes into 300 15 times. And then you got it. That is your answer. All right, last section. This is more tangent line properties. First one says if two segments from the same external point, so right here, these segments come from the same external point, so BA and BC, are tangent to a circle, then they are congruent. So check it out. They both circle at 90 degrees, so AB would be congruent to BC. If a polygon is circumscribed around a circle, then all sides are tangent. Okay? So what that means is this, guys. If any polygon is circumscribed by the circle, it could be a triangle, square, pentagon, hexagon, heptagon, and whatever. They're all going to be tangent, which means all these little pieces are congruent. Okay? All right, check it out. Number 10 says find each value or measure. Assume that segments appear to be tangent are tangent. So we're going to assume that these two lines are tangent, which means this. If they're tangent, those are congruent. Set them equal, solve for x. 5x plus 23 is 8x minus 19. Subtract the 5x over. 23 is 5x minus 19. Add 19, that gives me 42. 5 goes in there 14 times. This should have been a 3x right here. Sorry about that. 3x, 3x. 3 goes in there 14 times. 11, assume that these two lines are tangent, which means they're congruent. Set them equal. 14x minus 13 is 8x plus 5. Subtract the 8x over. Add 13 over. 6x is 18. 6 goes in there 3 times. But it says find PQ, right? Take that 3, plug it in. That comes out to be 27. Number 12 says find SV. So I got to figure out this piece right here. I'll just call it Y, right? Well, first I got to find X. Then I got to use some Pythagorean theorem stuff, right? So let's put in the 90 right there. We know we've got the 90s. All right, so first, solve for X. Set the two tangent lines equal to each other. 10x minus 41 is 4x plus 7. Subtract 4x over. Add the 41 over. Divide by 6. Goes in there 8 times, right? If I take that 8, I plug it right there. That comes out to be 39. Pythagorean theorem, just like the first page. A squared plus B squared equals C squared. So 39 squared let's see here. 39 squared plus 17 squared equals Y squared. 39 squared plus 17 squared is 1810. Square root that. That comes out to be 42.5. So SV is 32.5. 2 more. Find the perimeter of triangle DEF. All right, remember, guys, just as property up here, you got a lot of congruent pieces. This one goes fast. If that's 16, this is 16. That's 9.5. That's 9.5. That's 11. That's 11. Just add them all up. Add up all the outside measurements. Your perimeter comes out to be 73. Super easy. 14. If that's 27.1, this is 27.1. Now check this out. This whole piece is 52.5. We'll subtract off that, then you have this piece. If you do that correctly, that comes out to be 20. I can't see. It's here. 52.5 minus 27.1. 25.4. This would also be 25.4. If that's 23, that's 23. The whole thing is 37.5. Subtract off the 23. You're left with 14.5, which this would also be 14.5. Add up all the numbers on the outside. Do that correctly, it should come out to be 180 for the perimeter of PQRS. That's it for tangent lines.